This is page 11 from section 10.5. Notice the vertex of a parabola, which we noticed on the other page, is the midpoint of the segment between the focus and the directrix. So the vertex is always smack dab right in between the focus and the directrix. So this is just the equation in general when the vertex is not the origin. So you can write it like this. If the vertex is the origin, it's in this form. If it's anything different, you could write it like this. That's what it's trying to show you here. So let's just go to example 3. Example 3 is not in good form. So if we get it in good form, we can then figure out the characteristics and graph the parabola. So step 1, what I'm going to do is the 4y minus y squared, I'm going to move to the other side. So it says y squared minus 4y equals, or really here, plus x plus 1 equals 0. Then I need to complete the square. So to complete the square, what I need to, if I take half of negative 4, that is negative 2, squared is 4. I'm going to add 4 to each side. So if I factor this, half of negative 4 is negative 2, that's y minus 2 squared, plus x plus 1 equals 4. And then to get that in this form up here, I could subtract 4, and I get x minus 3 equals, this we can move over to the other side, is negative y minus 2 squared. And that's actually in good form to graph this. We could leave it like this. What that means is this. The vertex, if we set each equal to 0, is 3, 2. That's the vertex. So I'm going to plot that right now. To find P, I'm going to just set 1 over 4P equal to the coefficient here, which is really a negative 1. And I can solve for P. If I put this over 1, I can cross multiply. It's negative 4P equals 1. Divide by negative 4, P is negative 1/4. And then horizontal or vertical, because it's an x equals equation, it's going left or right. We would call this horizontal. We know it's going to the left. So P is negative 1/4. So if this is the vertex, since it's going left, we know the focus is left 1/4. So if I go left 1/4, we could say the focus is 2 3/4, 2. And if the focus is 1/4 to the left, the directrix is 1/4 to the right. And again, the directrix is a fixed line. So if I go 1/4 to the right and it's a vertical line, we would say the directrix equation is x equals 3 1/4. So that would be a sketch. So the vertex is 3, 2. And if you wanted to come up with some more ordered pairs, if we solve for x, we could add the 3 to the other side like this. And then we could just make an xy table. So if x, if 3, 2's an ordered pair, I could pick points close to 2, the y coordinate. If I plug in 1 for y, I get 2. If I plug in 3 for y, I also get 2. So these would be some other good points on the parabola. 2, 1, and 2, 3. So if I want to make a better sketch, it's going to look something like this. Example 4, same thing. We're going to complete the square. What I'm going to do here is this. Step 1, I'm going to isolate the x squared minus 8x. The negative y plus 18, I'm going to move to the other side by adding y and subtracting 18. And then I'm going to complete the square. Half of -8 is -4. If we square it, we could add 16 to each side. And then if we clean this up, that would be x minus 4 squared equals y minus 2. I could get y alone, which I'll do in a second, but right from here, it's in good form to find the vertex. If we set these each equal to 0, we're going to get 4 and 2. That is the vertex. 1, 2, 3, 4, comma 2. And then what I can do is this. I could actually get y alone. If I add 2 to each side, I get this. So if I want to leave it in that form, I can. The coefficient in front of x minus 4 squared is really a 1. So to find p, just set 1 over 4p equal to 1. And then I can solve for p. I get a quarter. So it's a y equals graph. It's going to go up in this case. The focus is going to go up a quarter. So if here's 4 comma 2 and I go up a quarter, focus will be 4 comma 2.25. The directrix will go down a quarter from the vertex. So if I go down a quarter, the y value is changing by a fourth. So it'll be y equals 1.75. Since the graph is going up, it's vertical. And then what I can do is just make an XY table, pick a few points to the left and right of the vertex. So if I said x is 3 or x is 5 and plugged in, I would get 3 for each. So that'll help me just solidify the sketch a little more. Here's 3, 3, and then here's 5, 3. So here would be a sketch of the parabola. So that's examples 3 and 4 from page 11 from the chapter 10 note packet.